All right, welcome to video number 8. That says video number infinity. That's not what I meant. This is video number 8 today. That reminds me of, probably by now I've told you a hilarious joke about sideways numbers in class. If I haven't told you that joke yet, come in tomorrow and remind me and I'll tell you. It's probably the funniest joke that I have. And I know it's hard to differentiate which jokes are funny because they're all so funny, but I particularly like the sideways numbers joke. So if I haven't told you it, remind me. If I have told you, think about it right now and laugh to yourself about how funny it was back when we told it. Your warm-up problem today involves simplifying radicals. I'd like you to try to take the square root of 108 and reduce it to lowest terms. Remember, that doesn't mean type in square root of 108 in your calculator and get 10 point whatever. But what we're trying to do is break this square root, break this radical down into lowest terms. So go ahead and try that now. Good. All right, let's see what you have. The idea here is to break 108 down into smaller factors. Any factors work. You know, a lot of times if I'm not sure where to start, I just realize that that's an even number, so 2 must go into it. So I'll just take 2 out. And then I get another number that's even, so I take 2 out again. Okay, 27, that's 3 times 9, and then I can break that down to 3 times 3. Remember, it doesn't matter. You might have started with 9 times 12. You might have started with 4 times 27, 6 times 18, 36 times 3, 54 times 2, like I did. It doesn't matter where you start. Keep breaking down until all of your factors at the end of your factor tree, at the end of all the branches, are prime numbers. They can't break down anymore. Look for pairs. We have a pair of 3s. That means a 3 comes out. We have a pair of 2s. That means a 2 comes out. Those numbers will get multiplied together. We've got a leftover 3 that doesn't pair up. It stays inside the radical. So we end up with an answer of 6 radical 3, or 6 times the square root of 3. Right? And remember that that is a number that we call an irrational number. Quick way to tell if you have a number that's irrational: if you put it in your calculator, you have a decimal, and that decimal does not stop. It's non-terminating, goes on forever. It's non-repeating. There's no pattern to it. And if you were to type square root of 108 in your calculator, you would see that, and you get 10 point, I think 3 something something something. And there's no pattern to it. It would go on forever. It fills up your whole calculator. So what we have here is an irrational number. Numbers that you had seen before yesterday, but maybe weren't used to the terminology or hadn't seen one in a while or hadn't talked about what it meant to be irrational before yesterday. Today we're going to talk about an entirely new type of number. You maybe think at this point, you're in high school, you've kind of seen all the numbers there are. It's likely that you've never seen a number like the ones that we're about to talk about. Square root of 16, certainly you know the answer to that is just 4, which makes that we call a rational number. It's also we call a natural number, it's just a number we count with, or a whole number, or an integer, a rational number. And all those numbers go together into what we call the real number system. Every number you've probably learned about before: fractions, decimals, square roots, even if it's irrational, those are all we call real numbers, right? Which always leads somebody to say, well, is there something that's not a real number? Are there fake numbers out there? And actually there are. And so what I want to talk about today is, what if instead you had the square root of 16, you had a square root of negative 16? All right, well, the immediate answer somebody might think of as, well, the negative 4, right? Square root of 16 is positive 4. Maybe the square root of 16 is negative 4, but that's not the case. Remember that if we multiply negative 4 times itself, and negative times a negative will give us a positive back. And so negative 4 is not the right answer there. If you tried to put the square root of negative 16 in your calculator would throw up. It will not do that for you. It'll say error, it'll say undefined, it'll say syntax error, it'll say stop asking me this, I don't know, I can't do this. Your calculator doesn't think there's an answer, and that's because your calculator only deals with real numbers. And there are some exceptions to that. Most calculators only deal with real numbers, the numbers that we've talked about in the past. The number system that I want to talk about today is something called the imaginary number system. Imaginary numbers. So yeah, there really are fake numbers. They're called imaginary numbers. The idea of imaginary numbers is based on one new number that we're introducing into our number system. And that new number actually looks like a letter. It's I. I for imaginary. The imaginary number. We define the imaginary number. We say that I is the square root of negative 1. Right? We don't know a real number that we can multiply by itself to get negative 1. We've created one and called it I, the imaginary number. So if I said I times I, or I squared, would be negative 1. I is the square root of negative 1. So this helps us to simplify a problem like the square root of negative 16. If you think of this as, let's think about breaking this down, I guess. Breaking this down to the negative 1 times 16. Well, I know the square root of 16. I'm not going to go fill out the rest of that factor tree. I know the square root of 16 is just 4. That negative sign, that square root of a negative 1, makes this an imaginary number. So we write it as 4i. Looks like 4 times I, like a variable. But remember, I is just a number. It's just the square root of negative 1. So we say the square root of negative 16 is 4i. Right? When we take square roots of negative numbers, we're going to get imaginary numbers. It's by far the most common place that you see imaginary numbers. Right? And surprisingly enough, imaginary numbers happen in the real world. If you do anything involving electronics or circuits, you'll see imaginary numbers show up a lot. If you happen to be in a physics class, you could ask your physics teacher about that. If you happen to be taking an engineering class, you could ask your engineering teacher about that. These imaginary numbers do show up in the real world in a lot of places, a lot of surprising places. All right, so now that we've learned about this imaginary number I, we're going to get that I involved in all the things that we learned how to do with numbers long, long ago. Right? And the first thing I want to talk about is how this imaginary number relates to simplifying radicals. If I want to simplify something like the square root of negative 12, my process is still going to be the same. I'm still going to break this down into factors. But the first thing I'm going to do is break it down into a negative 1 and a positive 12 in this case. I'm going to break this down, get that negative out of the way first, like so. Then go ahead and break this 12 down like you know how. 2 times 6 could work, 2 times 3, I think that's it. We have a pair of 2's, so a 2 would come out. We have a leftover 3, so the 3 would stay in the square root. And now we have this negative 1. Remember, that means our answer is going to be an imaginary number. It's going to have an I in it. You generally see the I written before the square root. So you'll see the I here most of the time. Right? Your answer will be 2i radical 3. 2i times the square root of 3. You will sometimes see it written as 2 square root of 3 and then the I out here. And that's okay. But usually you see that I before the square root. The reason is you don't want that I to sneak back into the square root. Then you've got the square root of I, and that turns into a big mess. So more than likely you're going to see the answer written like this, with the I before you get to the square root part. But our process, notice, is the same. We break down, we simplify that radical just like we did yesterday. Only with the negative in there, it makes our answer an imaginary number. Okay? I'll let you try one of these. Have you tried to simplify the square root of 98? Okay, you tried that. All right, we're going to break this down. Take out that negative 1 first, so we can just deal with the square root of 98. Even number, so I know 2 goes in there 49 times. Oh, that's good. I know 49 is just 7 times 7. So I have a pair of 7's. 7 comes out. There's my pair. I have a leftover 2. 2 is going to stay inside the radical. I've got my imaginary number I, right? And that's where that square root of negative 1 is coming into play, right? That's how we break down square roots that are imaginary. Again, process is the same, just instead of our answer being a real number, or an irrational number, and irrational numbers are real, what we've got here is an imaginary number. It's got the I. Right? Last thing I want to show you today, and this is sort of a preview of tomorrow, is how we would handle something like this. 3 plus the square root of negative 25. How would we reduce that to lowest terms? Well, if I ignore the 3 plus for a second, and just think about the square root of negative 25, based on what we've learned today. I know the square root of 25 is just 5. And then since I'm taking the square root of a negative, I got an imaginary number. So if I just said reduce the square root of negative 25 to lowest terms, you just say 5i. Now, what about this 3 plus? The point that I want to make here is these are not like terms. The 3 and the 5i are not like terms, and they can't be combined. You can't turn this into 8i or just 8 or anything else. These are not like terms. So our answer is simply just to leave it as 3 plus 5i. Right? What we end up with here is something that's simplified all the way, yet it still has 2 different kinds of numbers in it. It's got a real number here, and it's got an imaginary number here. What we're going to see tomorrow is that this is something called a complex number. We're going to talk about what it means to be a complex number, and then how to do some math with complex numbers, how to add, subtract, multiply, and divide complex numbers, since that's the basis for a whole new number system that you haven't seen before. All right, so I think that's it for the day. Now that you've learned a whole new group of numbers, we'll practice handling those numbers in class tomorrow, and then we'll deal with the mathematics behind using those numbers in the near future.